practical 6. This is a practical on mapping, basic mapping. Today it's going to rain. I hope not in the next 20 minutes. But so we're gonna do this very quickly. And but the main thing is, even though it's a small plot that we're going to use for this practical, the principle is the same as if it's a big plot, where you need to sketch, to make a map of the plot, and where you need a pretty accurate, enough for your purposes, but to put into practice what we covered in the theory class with regards to mapping. Okay, so what we're going to do is I've put a mark on the ground there. Can somebody please point to the mark? Because remember we said that you go first to the area, you look at the area, you label the area. So over there I put a point to it, please. Point. Yeah, there's a mark on the ground there. You made a mark. That's one of the corner of the plot, and that's point A. You put in the ground here. Can you please point? Another mark in the ground. That's the other corner. So from there to there is one boundary of the area. That is point A. This is point B. So this is the line AB. We put in the ground also another. You can see Ken there, our chief technician. He's put in the ground another point. Yeah, that's point C. So A, B, C. So this is boundary line BC. And somebody who has the mark? Yeah, you go over there. Go to the on the cement there. See that nice white? Go there. White. Yeah. Little bit. That's where you can make a mark in the ground. Okay. So that's point D. So now we have a rectangle. A, B, C, D. That's line AB, BC, CD, DA. DA back to A. So that's our rectangle we are going to use to draw the map. Remember, the idea is we draw the map of this particular area, and then you come up with a scale where you can draw this area into an A4 piece of paper, no bigger than A4. This is somebody hold up an A4. Yeah, hold it up. Yeah, that one. That's an A4 size paper. So you need to work out a scale in order to be able to draw a map of this area on that size of paper. And then submit that as your report. Now, the other requirements for this is we need to put in an offset. An offset, as you remember, is something that is located inside the area that we want to put in the map. Where you remember, we said in class, you need to find the perpendicular or your boundary line, and then you need to find a perpendicular distance to the offset in order to locate the offset on the map. That's the other one thing. The third thing we need to put in is the north. This is a compass. We need to put in the north line. You can use this line. I know north is somewhere around there. So you can use this line because it's closer to the north, line PC, or you can use line that's TA to put in to measure, because if you know the you measure north according to that line, and you can put that in the map. And the last thing we need to do is we want to put in what's called a check line. a check line. If you read the notes, you find all this information in there. A check line is a line that you measure. While we are doing all these measurements, you make an extra measurement, a check line, which you use later. What you do is you draw the map using all the information that we collected. And then after that, you use your ruler, you measure the distance of the check line, and you calculate it and find out what is the actual distance, this time using the map, the distance from the map. You convert it to the actual field distance, then you compare it to what you recorded today. So the check line is not a line that is used to create the map, but it's a line for you to compare. Compare, because if your map is very accurate, your distance you found out of the check line from the map would be very close to the distance you actually record today. You see the thinking? The check line is for comparison purposes, but you don't use it to make the map. Anyway, read the notes, it's all there. So, Ken, can you bring our tapes, please? Yeah. The other thing is we need to divide it to make a triangulation line, as we said. So there are two possibilities. One is BD or AC. Let's use BC. Any of the two would be fine. So let's come and measure one first. Let's measure T8, and so that we can also measure the north line at the same time. So the one who's with the tape, get one with the other one side of the tape. Give it to him, and you stretch it from that. Yeah, you go. One one hold the tape, and the other one bring the tape. Stretch the tape here. We'll come and so that's point B, and then you come here and you read the tape. You need to make the measurements in 3 decimal places using the meter. I guess you can see the. So make sure it's in a straight line. This is point A here in the ground. So if possible, you need to turn it up to the meter side. You're on the foot side. Turn it over. Somebody come and flip over the. Put up the meter side, not the foot side. This is the foot side. Yeah. Okay. Now, turn it out and then lie it on the ground, and you all come here and let's make the measurement together. Yeah. It's straight now. Yeah. Okay. Now, put it down on the ground. The tape. Put it down. Put it down. Yeah. Take your hand off. Okay. Okay. Take your hand off. Yeah. And you? Yeah. Yeah. Now make sure you don't touch the tape, otherwise you're gonna. Yeah. I just wanted to lay down on the ground so that all of us can come and. Okay. You can see here that up to here it's 18 meters. That's the whole numbers. Whole meters is 18. Now we want to read it to 3 decimal places. It's more accurate that way rather than counting the number of centimeters and the number of millimeters. Because it's more accurate to read in 3 decimal places. And I am looking at this point as the actual measurement. Yeah. Where the pencil is, where the mark is. So up to here is 18 point something. These numbers is the first decimal place. So 18.1, 18.2, we don't reach that yet. So up to here it's 18.1. That's the first decimal place. Now between 0.1 and 0.2, we have these other numbers. That's the second decimal place. So 18.16. And then between 6 and 7, there are 5 divisions. Each of those divisions is 2 millimeters. But so each of those lines is a 2, 4, 6, 8. So up to there is 2. So 18.162. 18.162. Just watch the tape. The tape. Yeah. Don't touch the tape. The north reading. Now you look. This is the compass, and this is the red line of the compass. Now, the north line is this line here. And the north line always points to the north. Magnetic north, remember. So that's magnetic north. And this is the red line. You line up the red line with the tape. So I'm lining up on this side of the tape. Like this. Yeah. Yeah. The red line is now lined up with this side of the tape. So that's the direction of the 8. Because this is 8. Now, this is north. I thought north was somewhere there. Maybe it's attracted by your... Can you move away and see? No. No, that's correct. So this is north. Okay. Now, you make the reading, but you can see it starts from 0 here. Then it goes right round to the red line, and it's reading 280 degrees. This way. So, in your sketch, give me your book. In your sketch, you should write, this is the A, and you're looking at the north line that looks like this. And the angle it says is, this one here is 100, 280 degrees. Now, it's 360 degrees all the way around. So this angle here would be 360 minus 280. So it's 120. True. So this angle is 120 degrees. That means line AD makes a 120 degree angle with a magnetic north, because this is magnetic north. Now, as I said before in our class, here in Samoa, the angle of magnetic declination, this is north, and magnetic north. And Samoa is, if this is Samoa, makes a 13 degrees too much to the east. That means we need to shift this line to the left. in order to get the true north. So that's 120 minus 13 gives you 7, 0. 0, yeah, 1. So true north, sometimes called the geographic north, but normally just north, is 107. So in your map, you get the compass and you make an angle which is 107. That's where north is. Yeah? Any questions? Meter notes is all there too. Okay, so we've got our magnetic north. Let's do the offset. So come this way. Watch the tape, don't touch the tape. Let's do the offset. Line PA to locate the offset. This is the offset. Just imagine this is a tree or something. We're gonna put it in the map, this one. So there are 2 readings we need to make. We are going to use, whose book is this? We're going to swing the tape. Who? Come. You help me do this. Okay. So you come and hold it to the. Down here or something. Yeah. Hold it to the middle of the. To the middle. Okay. Don't touch the tape. Always look down and don't move the tape. Yeah. Okay. It looks like it's over 2 meters. Take up the tape. Don't touch the tape. You're gonna move it. Take up the tape. Bring the tape up. Okay. It's over 3 meters. So I think an ideal move distance would be let's use a nice 4 meters. This is the 4 meter. So we are swinging the tape to find what we want to do is to find the point on line 18. Remember line 18 starts from there, 0 goes that way. So we want to find the 2 measurements from there in order to determine at what point is the perpendicular line on here. So we are using the 4 meter mark. This is the 4 meter mark, and I'm swinging it so that it just touches here. Yeah, at that point. 9. Somebody come and make the reading. I'm looking at here. This one. Where the 4 meter just touches. You move the
10.8 now. This one here.
No.
Yeah, it's this side. This is 4.
Okay, it's 10.9.
Okay, just a minute.
So
4 meters.
So if it is 10.9.
10.9. So it's 10.9. Yeah, it's up. It's going here. Huh?
Here.
See, that's where the 4 meter comes. It's coming from there. It's 10.90 because we don't pass the 1. 10.902. 10.902. Yeah? Okay. Take, don't move the same 4 meters and make the reading on this side. Here, somebody come and make this reading. This one.
5.3.
It's 5. 3.9. Each of these is 2. Yeah. 8.6. 3.8. Wait. This is the mark. Yeah. This is the mark. So.
4, 6. 5.336.
Yeah. 5.336 is correct. Agree? Yeah. Okay. Now, who has the numbers?
Apa tu ni?
Who wrote down the numbers? Yeah. The big number.
10.902.
Yeah. Minus the smaller number.
5.33.
Yeah.
No, I mean 5. 5.336.
Yeah. Note down the numbers. You need these numbers for your calculations. What's the first number?
10.902.
10.902. Write these numbers down. Second number?
5.336 meter.
5.336. Big number minus small number equals, use the calculator.
5.566.
Divide by 2.
2.78.
Add to the small number. Somebody check this.
8.119.
8.119. Yeah, that's where the perpendicular line is.
8.11.
8 what? 8 point what?
119.
Yeah, fine. 8.119.
821.
197.
1.
That's where the perpendicular line is located. 8.1
6, 8, 9.
yeah, between, yeah, right there. That's right. That's where the perpendicular line is located. So note that down because you need to use that to locate the perpendicular line this way. And then you use that to make the measurement. So this is the distance from the offset, perpendicular distance to line T8. Yeah, where's the mark? Yeah, now make this reading. 2.8 9 2.8. No, it's past the 9. I'm looking at this side of the tape. 2.90. 2.904. Huh?
Yes.
2.904. Yeah? Murray, you got this?
2.904.
2.904.
How much?
2.904. That's the distance from the offset along the perpendicular to line D8. Ah, okay?
Yes.
Okay, so the rest you can do. You need to measure line DA, oh yeah, sorry, AP, PC, CD, we already got DA, and then the triangulation line. I think use this one. You can use that one, which is CD line. Let's do the check line together. Yeah, so two of you come and measure the check line. Can somebody suggest a deadline, check line? Which would, you remember the idea of a check line is that you don't use it to make the map. After you finish the map, then you use a ruler, measure the check line on the map, convert it back to the actual distance, and then you use that compare to the reading that you make today. If the idea is that you compare what you got from the map to what you actually measured here, in order for you to indicate how accurate your map is. You see what I mean? That's why it's called a check line. It's for you to check the accuracy of your map. If it's off by 10 meters, you know something is terribly wrong with your map. But if you're off by just maybe 5 or 6 centimeters, that's accurate enough. Well, when I see your report, I expect you to make that comparison, to discuss what you think the accuracy of your map is, and you use the check line for that. Now somebody, can you suggest a check line that's easy to measure in the map? This line is independent of the measurements that you will use for making the map. Okay, I'm suggesting you measure from the offset to one of the corners. Maybe this one to the, or maybe this one to that corner. So measure, somebody come. Measure the offset, but you need to, you need to use this side of the, come. Who was holding it before? Put it to where you were holding it before. Yeah. So, make that reading 3 decimal places. Huh? 8. 12.8. 6. 12.886. 12.886. So that's the check line. This is that information. You leave it out of your calculations. You just note it, and after you create your map, then you use the map to find out this distance from the map. Once you find that out, then you look at this recording and compare the two. See how close they are. If they're very close, it means your map is very accurate, because this is not used at all in creating the map. Yeah? Okay. Ang lai akin. AP, PC, CD and the triangulation line from here to, so that would be CD. So you do that, start from there. No, since the, yeah.
Bang. Let's say play the marker. The first marker, 8.8.
And then make this reading. So make all the readings 0, 0 to whatever, 0 to here, 0 to there, 0 to there, 0 to there. 12.5, 9,
Achina.
2. 12.592. Huh? 12.9. 2. Yeah, 12.5.
12.5.
9.
92. 592.
Yeah.
Point B, eh?
No,
AB.
A to B.
AP.
That's
Okay,
A to B. That's AB. So somebody do the recordings, huh? 12.592.
C.
Yeah, you keep the recordings and then give it to Maury to put down in a piece of paper, for the online students. 0 here.
Listen.
So you go over here. So this is PC. Yeah.
19, 4, 3,
19,
4, 3, 4.
19.4, 34. 19.434. This is
Bang.
CC.
B to C. T to D.
CD. CD.
Eight point seven.
04.
8.7.
You don't reach the one, let's do 0. 8, what? 8? 8.706. 8.706. And then 8.706, that's line CD. So now the triangulation line PC. Somebody go to that mark and A to C. From A to C. To C. B. A, C, D. A, D. A to D. B to D. C, D. C, D. B to D.
Ah, yes, P to D.
20.9.
20.9,
7.
7,
8.
8,
20.978.
978. Okay, so that gives you all the measurements you require. Remember, you need to draw the map on an A4 paper. Use an appropriate scale that fits the map into the A4 paper, and then put in the north line, and also put in the offset. Now read the practical manual. It gives you all the requirements that are needed, and remember the marking rubric follows the instructions in the manual. So I'm not sure if you are required. Do you have a copy of the manual? Are you required to calculate the area? Huh? Okay. So you are required. So you need to calculate the area. Use the formula for the two triangles, or for the triangle with three sides known. Which is the area is equal to the square root of s multiplied by s minus a, s minus b, s minus c, where s is equal to a plus b plus c divided by 2, and where a, b, and c are the sides of the three sides of the triangle. Because you now that's one way. The other way you can also do here is to from the map. Now that you have the map, you create a height. But you can make a you can make a height of the triangle because you've got the shape there in the map. So you can create a height, and then you can use half the base times the height. But you've got to do the conversions properly. Read the notes on how to do that. It's the notes are very intensive in that it explains all of these methods in detail. So you should carry that out without any problem. Any questions? Final questions? Well, thanks God that we didn't have a rain today, and I hope you learned something in all of our practicals that we've done together. This is the last practical. Now the main thing is, even though the due dates are already in black and white on Moodle page, main thing is that you submit them before we do the final finalization of all the grades. But at least in the next couple of weeks, make sure you submit everything. Any questions? Okay, so we end there and you go and work on your practicals. Are we supposed to have a quiz this week?
Yes. Yes.
Yes. Oh, I gotta go and open the.
Go ahead.
Is it open yet? Okay, sorry about that. I'm going now to open the quiz.